Hi, in this lesson, we're going to be talking about how to evaluate a function. When you see the word evaluate, think of the word value. So we're finding the value, the y value that is. We're calculating the outputs for the function. To evaluate a function means to find the output of the function for a given input. So you'll be given an x value or an input value, and you'll be calculating the y value or the output. Now, when our function is given as a table or a graph or a set of ordered pairs, we can easily read the outputs from the display. Let's look at some examples of this. Here the directions say, for the given function, find g of 2, g of 0, and g of negative 2. Let's see what functions we have here. Okay, in part A, we have the function g of x is equal to 0, 7, 1, 7, negative 1, 4, 2, 11, and negative 2, 8. This is a function, and its name is g. We're asked to find g of 2, g of 0, and g of negative 2. You should recognize this as function notation. The 2 inside the parentheses means that the x value that's given is 2, and we want to plug in 2 as an input to the function g. So if we plug in 2 for x, what comes out for y? Let's look at the ordered pairs and see what y values are paired with an x value of 2. Here's our answer. When x equals 2, our output y equals 11. That means g of 2 equals 11. 11 is the output that is paired with 2. And that's all we wanted to find out. Let's look at g of 0 now. What y value is paired with 0? In other words, when x is 0, what's y? I hope you saw that g of 0 is equal to 7. And remember, since we're talking about a function, there's only one output here. Lastly, we want to find g of negative 2. Using negative 2 as our x, what's the y value? It's shown in this pairing here, negative 2, 8. So we have evaluated this function g for each of these given inputs. Let's look at part B now. It's just as straightforward. G of 2, g of 0, and g of negative 2. Go ahead and write your outputs, and we'll check your answers in a moment. All right, g of 2 is equal to 2. G of 0 is equal to negative 2. And g of negative 2 is equal to negative 6. So we've looked at our function in the form of a table and a set of ordered pairs. How about a graph? Here, this graph shows the function g. Remember, all the points on the graph are the ordered pairs that are in the function. So let's look to evaluate g of 2, g of 0, and g of negative 2. If x is 2, what's the y value? Watch the scale here. In this graph, each tick mark represents 2 units. So an x value of 2 is here. Let's look to see what the y value is. The y value is also 2. So our output for an input of 2 is still 2. Now let's find g of 0. Here's the point on the graph that has an x coordinate of 0. What's the y coordinate that's paired with it? Well, this is the point 0, 0. So our y coordinate is 0. G of 0 equals 0. And lastly, g of negative 2. Here's x equals negative 2. The point on the graph that has that x coordinate is here. And the y value, again, is negative 2. So when you have a graph or a table or a set of ordered pairs, there's no calculating to do. You're just reading the outputs from the graph. Now let's look at functions that are given as a formula. If the function is defined by a formula, then we must plug in the value of the input variable and work to find the corresponding output. In other words, whatever we're given for x, we have to actually substitute it in and do the calculation. Those x values, or those input values, can be numerical values, just plain numbers, or we can also plug in algebraic expressions. In other words, we're using an algebraic expression as the input to the function. Regardless of whether our input is a number or an expression, we always have to simplify our outputs. So let's look at some examples here. Here's our function. F of x is equal to x minus 2 over x plus 9. Here's one of those rational functions again. But this time, we're not finding its domain, we're evaluating the function. Remember this notation. This is read f of 7. That means we're using an x value of 7 in the function. So we plug in 7 for x. F of 7 is equal to 7 minus 2 on the top and 7 plus 9 on the bottom. Now let's do the arithmetic. 5/16 is what we have initially, and as we look at that to see if it needs simplifying, nothing goes into both 5 and 16 to reduce that. So our final output is 5/16. That means for this function, when x equals 7, y equals 5 over 16. And that xy pair is also going to be a point on the graph of this function. Let's move to the next example. Given the function h of x is equal to x squared minus 2x plus 5, find h of negative 4. Again, this notation means use x equal to negative 4 in the function. So everywhere we see an x, we'll replace it with the negative 4. Be careful to use parentheses around the negative 4. So x squared means we have to square the negative 4. Minus 2 times negative 4 plus 5. If you like, you can use your calculator to help you do the arithmetic here. And if you've entered the expression into your calculator correctly, you should get an output of 29. In our last example, we have the function capital F. Here, f of x is equal to negative 3x plus 8. And now we want to evaluate that function with the input a plus 6. This means wherever we see the x, we're going to plug in this entire expression, a plus 6. So let's write that out. F of a plus 6 is equal to negative 3 times a plus 6. We need the parentheses because we're multiplying that entire expression by that negative 3, plus 8. So now we need to simplify this. Let's distribute the negative 3. Plus 8. And now combining the like terms gives us negative 3a minus 10. And that's our completely simplified answer. Evaluating a function is simply a matter of plugging in the given input and working to find that output.